some practice questions on what we have done and some explanation as well. So here, the first question we have, it says, this is a tricky question, and I'll point out some things about it. The question says, the amount of heat required to raise the temperature of a body is A. Thermal energy, B. Thermal conduction, C. Heat loss, D. Thermal capacity. I'll read the question again. The amount of heat required to raise the temperature of a body is A. Thermal energy, B. Thermal conduction, C. Heat loss, D. Thermal capacity. Now, this is a trick question. This is a trick question, and it's very easy, very, very easy, but it's tricky, especially if you've not come in contact with this course before. But I'll break it down for you. First of all, I would like to advise you, um, whenever you're writing any physics exam, physics in particular, physics and chemistry at some point, but physics most especially, if you're given an objective to answer in physics, please answer your questions from your options. Start from your options because the options normally have the units of it has the answer obviously, but then there are the units. Your answer comes with a unit, and you know in physics your answer must come with a unit, except for um cases where the figure doesn't have a unit. But in our case here, obviously we don't have a unit here. Obviously all these have units, but then we are not seeing the unit here. So before I come to this option to explain what I'm saying, the question says the amount of heat required to raise the temperature of a body is, and remember I told you that when you're defining heat capacity and specific heat capacity, you should be conscious of one word, and that word is what I call unit mass. And I told you that whenever unit mass comes into the definition of heat capacity or specific, or whenever the term unit mass comes into this kind of question, just know that the answer is specific heat capacity. But then they didn't even tell us, they didn't use the word heat here in the option. So how do we solve it? But I want to remind you that the word thermal is the same thing as heat. Thermal is equals to heat, thermal energy, thermodynamics. Whenever you hear this word thermal, they are referring to heat. And then see the trick they did here. They tend to put heat here again in the question to confuse you. But don't let them confuse you because the answer to this question is thermal capacity, which means heat capacity. It's not thermal energy because we are referring to this whole topic as thermal energy. I told you that heat is a form of energy. So this is the energy they're talking about that is transferred from hotter region to a colder region due to temperature difference. That's the definition of thermal energy or heat energy. So this is heat. The meaning of this is heat. The meaning of this is heat. So thermal conduction just means like conducting heat. And this one means thermal capacity, which is what we're talking about here, heat capacity and thermal capacity. They are still the same thing. And now the question says the amount of heat required to raise the temperature of a body. The amount of heat required to raise the temperature of a body is always heat capacity, not specific heat capacity, because the question did not say the amount of heat required to raise the temperature of a unit mass. Whenever you hear the word a unit mass, then it means we're talking about specific heat capacity. And here the answer is D, thermal capacity. So this is this is our answer. And then um note, I want you to get this in your head. JAMB will ask you a question. The instrument used in measuring temperature is thermometer. The instrument used in measuring temperature is thermometer, and the instrument used in measuring heat, the instrument used for measuring heat is called calorimeter. Remember, temperature is a fundamental quantity. Temperature is a fundamental quantity, while heat is a derived quantity. Now, let's go to the second question. The second question says, what quantity of heat will be given out if a bar of brass of mass 4 kilogram? What quantity of heat will be given out if a bar of brass 4 kilogram is cooled from 95 degrees Celsius to 20 degrees Celsius, taking the specific heat capacity of brass to be 380 joules per kilogram per Kelvin. Now, let me say this here. Usually, the specific heat capacity of every object or substance or body is constant. Is unique. It's constantly unique to that constant, to that object. What I mean is that plastic has its own specific heat capacity. Water has its own. Mercury has its own. Iron has its own. Aluminium has its own. Every object, every mineral resource has its own specific heat capacity of specific heat capacity. In this case, we are talking about brass. Brass is an alloy and brass is a metal. And now, because we're talking about brass, we are using the specific heat capacity of brass. Also, water has its own. The specific heat capacity of water of H2O. H2O is the chemical formula for um for water. So we all know this is water. The specific heat capacity of water is 4,200 joules per kilogram per Kelvin. So whenever you're solving a question related to water, you definitely see this. They'll give you this, and normally JAMB will give you the specific heat capacity of the object that you're asked to find because they don't expect you to like have it off head. Not everybody will have it off head. You get so for the sake of this question, we'll be dealing with brass and we'll be making use of the specific heat capacity of brass. So now, solution to our question. The question says again, what quantity of heat will be given out if a bar of brass of mass 4 kilogram is cooled down from 95 degrees Celsius to 20 degrees Celsius? This bar of mass is hot. The initial temperature is 95 degrees Celsius and it now cools down to the final temperature 20 degrees Celsius. And now they're asking what quantity of heat will be given out during this process. And for us to solve this, obviously, we'll have to go and get our formula for quantity of heat. I'll write solution here. Solution. Solution. What quantity of heat will be given out if a bar of brass, 4 kilogram, is cooled from 95 degrees Celsius to 20 degrees Celsius? Like I said, this 95 degrees Celsius is the initial temperature and it cools from this 95 degrees Celsius to 20 degrees Celsius, which is the final temperature. What quantity of heat will be lost during this process? Recall, like we said before, recall that quantity of heat is equal to mass times specific heat capacity times change in temperature. If you want, you can do it this way. Quantity of heat is equal to m dot c dot change in temperature. It's still multiplication. Dot means multiplication. Or if you want, you can leave it like this. C change in temperature. Whichever one you want. Let's continue with our solving. So now we know that the quantity of heat, the formula for quantity of heat is this because the question says quantity of heat. What quantity of heat will be given out? What is the amount of heat that will be given out when this bra of mass 4 kilogram cools down from 95 degrees Celsius to 20 degrees Celsius? 95 degrees Celsius is hot. It means that this bra is hot. This bra iron, this bra metal is hot. And they're asking us what amount of heat will be lost if it cools from 95 degrees Celsius to a cooler temperature, 20 degrees Celsius. So for you to cool this thing down, it means that when you pour it water, you know that sound when you pour water on something hot, you know that sure sound that it makes. We don't know how this got to cool from to 95 degrees Celsius to 20 degrees Celsius. We don't know the method they use, but they're asking us what amount of heat will be lost. So for us to determine the amount of heat that is lost, we're using this formula. This is the formula we're using. Or any of them is still the same thing. We're using Q is equal to mass times C times change in temperature. And we know that Q here is the quantity of heat. Quantity of heat lost or gained. Quantity of heat lost or gained. But from this question, heat is lost because they're asking us what quantity of heat is given out. Whenever it's given out, it means that heat is lost. So for this context, the quantity of heat you're looking for is the quantity of heat lost. And now we have our mass of the brass metal. So the mass of the brass metal is 4 kilograms. So we write 4 kilograms. Specific heat capacity of the brass is equal to 380 joules per kilogram per Kelvin. And then change in temperature is equal to final temperature, theta 2, minus initial temperature, theta 1, is equal to theta 2 minus theta 1. That's the final temperature minus the initial temperature, Like I said, the initial temperature here is 95 degrees Celsius to 20 degrees Celsius because the brass is cooling from 95 degrees Celsius, which is hot. The word cooling means that it's coming down from a hotter temperature to a lower temperature. So it's coming down from this initial temperature, which is the hot temperature, to the lower temperature, which is 20, which is the final temperature. And that will give us 20 minus 95 equals to 75 degrees Celsius. Sorry, which will give us minus 75, which will give us equals to minus 75 degrees Celsius. 20 minus 95 will give you minus 75. And then we have to call our quantity of heat here X because we don't know what it is. So we call quantity of heat here X. So we say quantity of heat is equal to X. Now putting it back in our formula here, we say coming back to our formula, we say Q is equal to MC change in theta. X is equal to 4 times 380 times minus 75. X is equal to 114,000. Q is equal to minus 114,000 joules. So the quantity of heat lost is minus 114,000 joules. Normally, usually, when heat is lost, we would have a minus sign. Sometimes jam can be tricky. They might remove the minus sign and just leave the 114,000 like this joules. But note that we should put given out beside it here to show that it is giving out 114,000 joules. Then again, JAMB might not give you the answer like this straight up. Maybe they might leave your answer in standard form. Let's say A 1.0 times 10 raised power 3 joules, B 1.33 times 10 raised power minus 8 joules, C 1.57 times 10 raised to power 9 joules. D, 1.14 times 10 raised to power 5 joules. Whenever you see something like this, just know that you're changing this into standard form. And when you convert this into standard form, for us to convert this 114,000 into standard form, we write it out first. There's a decimal point here, an invisible decimal point, because normally this is 0.114000.00, but you wouldn't be seeing the point 00 there. But there is an invisible decimal point at the end. So all you need to do is to move your decimal point 5 places. One, it is not a must you have to move it 5 places. You have to move forward to this point. So you move one, two, three, four, 5. So this is 1.14000. Sorry, this is 1.14 times 10 raised to power because you moved 5 places. 5. So it becomes 1.14 times 10 raised to power 5 joules, or J, anyone. So this is our answer. Thank you.